This is Dr. S. Mohan Lakshmi, Head of the Department, Electronics and Communication Engineering from Rohini College of Engineering Technology, Kanyakumari District. So, in this lecture, we'll see about the third access IoT access technology, which is LoRaWAN. So, you will be able to define what is LoRaWAN, you will be able to describe the layers, as well as you will be able to explain the topology and security associated with the LoRaWAN at the end of this session. So LoRaWAN, what is LoRaWAN? It is a long range wide area network. So it was a physical layer or layer 1 modulation that was developed by French company named Cyclio. So later it is acquired by the Semtech, so which is quite famous thing. It is optimized for long range two-way communications and low power consumption. The technology evolved from layer 1 to a broader scope through the creation of the LoRa Alliance. So these are the LoRaWAN layers. You can see LoRa Alliance, Semtech, and again a LoRa Alliance. So it has specified certain bands, the physical modulation or the physical layer, the MAC layer, as well as the protocols like IPv6 or associated, and finally the applications. So Semtech LoRa modulation in the physical layer, it is based on chirp spread spectrum modulation. So this states to a lower data rate for receiver sensitivity to significantly increase the communication distance. It allows demodulation below the noise floor. It offers robustness to noise and interference, manages a single channel occupation by different spreading factors. So this enables the devices to receive on multiple channels in parallel. There is a gateway which is deployed at the center hub of a star network architecture. It uses multiple transceivers and channels and can demodulate multiple channels at once or even demodulate multiple signals on the same channel simultaneously. So these serves as a transparent bridge relaying data between endpoints, and the endpoints use a single hop wireless connection to communicate with one or many gateways. So, what is the data rate in the LoRaWAN? So, it depends upon the frequency bands and it is an adaptive data rate. So, adaptive data rate is an algorithm that manages the data rate and radio signal for each endpoint. It ensures that packets are delivered at the best data rate possible and that network performance is both optimal and scalable. So, endpoint close to the gateways with good signal values transmit with the highest data rate, which enables a shorter transmission time over the wireless network and the lowest transmit power. So, it is obvious. So, endpoints at the edge of the link budget communicate at the lowest data rate, and of course, it will be expecting or you will expect a high transmit power. And it has its ability to handle various data rates via the spreading factor. So, devices with a low SF will achieve less distance in their communication but transmit at faster speed, resulting in a less react time. A higher SF will provide a slower transmission but achieves a higher reliability or longer distance. So coming to the MAC layer, so this takes advantage of LoRa physical layer and it classifies the endpoints to optimize their battery life and ensure downstream communications to the LoRaWAN endpoints. So here there are three classes of LoRaWAN devices: Class A, Class B, and Class C. Class A, this is the class which is the default implementation. So this is optimized for battery powered nodes, allows bidirectional communication, where a given node is able to receive downstream traffic after transmitting. There will be two receive windows which is available for each transmission. Coming to the class B, this is designated as experimental. So here node or endpoint will get additional receive windows compared to class A, but gateways must be synchronized through a beckoning process. Whereas in the class C, it is particularly adapted for the powered nodes. So this enables the node to be continuously listening by keeping its receiver window open. And this is the format for the MAC layer, where it has a 1 byte MAC header, a variable byte MAC payload, and a MIC that is 4 bytes in length. The MAC payload size depends on the frequency band. So we have seen in the lower layer different frequency bands. So on the data rate ranging from 59 to 232 bytes for the 863 to 870 megahertz band. So it will be of 59 bytes for the lower band and 230 bytes for the higher band. So coming to the topology. So this is the topology involved over here. You can see the endpoints, you will have the gateways, you have network servers and the application servers. So these are all, as we have seen in the diagram, it is all star of stars topology. So the infrastructure consists of endpoints exchanging packets through gateways, which will act as bridges with a central LoRaWAN network server. So these gateways connect to the backend network using standard IP connections, and endpoints communicate directly with one or more gateways. So LoRaWAN gateways act as bridges that relay between endpoints and the network servers. Multiple gateways can receive and transport the same packets. When duplicate packets are received, then deduplication is a function of the network server. So once you receive a particular duplication of a packet, then that will be deduplicated, which means that it will not be a existing one. So the LoRaWAN network server manages the data rate and radio frequency of the endpoint through the adaptive data rate algorithm. And here these endpoints transport their selected application data over the MAC layer, which is on the top of one of the supported physical layer frequency bands. The application data is contained in upper protocol layers. These upper layers could just be a raw data on top of the MAC layer, or the data could be stacked in multiple protocols. For example, upper layer protocols, a ZigBee control layer, constrained application protocol COAP, message queuing telemetry transfer. So we'll be seeing in the other lectures of these MQTT, COAP, JCL. And coming to the security, so here it is implemented in two layers of security. So one is protecting the communication, the other one is data privacy across the network. So protecting the communication is also called as network security, but applied to the MAC layer. So this guarantees the authentication of the endpoints by the LoRaWAN network server. It protects LoRaWAN packets by performing encryption based on AES. Each endpoint implements a network session key, that is NWKS key, used by both this itself and the LoRaWAN network server. So this particular key ensures data integrity through computing, and it will check the MIC of every data message as well as encrypt and decrypt MAC only data message payloads. So coming to the second aspect, which is the data privacy. So this will generate one more key, which is an application session key. This will perform encryption decryption functions between the endpoint and application server. So this computes and check the application level MIC if included. So this ensures that LoRaWAN service provider does not have access to the application payload if it is not allowed that access. So here the endpoints will receive this particular key from the application owner. This key is most likely derived from an application specific root key exclusively known to and under the control of the application provider. So that's how the LoRaWAN security is maintained. And these are the possible questions. What is LoRaWAN? Describe the layers of LoRaWAN, explaining the topology and security associated with LoRaWAN, and what are the two levels or two layers of security in LoRaWAN. Thank you.